Okay, so we're gonna start talking about logic. As I mentioned, logic is kind of our second big topic in terms of computer science or programming concepts, variables being the first one. And logic is gonna allow us to do a lot more interesting things with our programs than what we've done so far. The basic idea behind logic is the process of making a decision. But our computers, even though they can do lots of stuff, they are not very complex thinkers. So when we have decisions that we want to make, we have to figure out a way to reduce it into binary, simple choices. So binary means there's only two options. So sometimes when you're making a decision, there's lots of options. So it's not just one option or another. But in order to break down making a decision for the computer, we have to break down the points of decision down to binary options. And so we can use lots of different inputs, different conditions that help us make those decisions. But we have to figure out how do we break it down for the computer to understand. So as a quick example, when you're deciding, making any really basic decision, so deciding what to wear on any given day, there's a process of different kind of steps that you go through. And when you're doing it, you're probably not really thinking about each individual component. You're just used to doing it, but you are making a series of binary choices. And those add up to a larger series of decisions. So for example, one binary option you might consider, is it cold outside or not? Obviously, the degree of how cold it is could vary. There could be different amounts of cold that you might be concerned about. But we can sort of generally say, is it cold outside? If it is, then I'll wear a jacket. You might have another series of decisions based on what the actual level of coldness is for different types of jackets. But we start with that basic, do we need a jacket or do we need no jacket? And then we kind of go from there. So making these decisions is going to kind of break down into smaller and smaller points where we have these kind of thresholds where you might say if it's lower than 60 degrees Fahrenheit, then I'm going to wear a jacket. If it's higher than that, then I'm going to skip the jacket part. Maybe I'll wear a sweater or something like that. So we sort of break down decisions into these binary operations. So in programming, we use Boolean values. Boolean is just a fancy word for true or false. It's named after one of the early computer scientists, this guy George Boole, from a long time ago. So it doesn't have it's just named after a person. The actual word Boolean doesn't really mean anything in particular. But it basically just means a value that's either true or false. So far we've used values like numbers and strings, which can be lots and lots of different things. A number can be 0 or 1 or -1 or 2. It has tons and tons of different values it can be. A Boolean really can only be two things, either true or false. And so we use Booleans along with conditional statements to make decisions in our program. In JavaScript, one of the things that is both useful but also very confusing is that values that are not Boolean evaluate to Boolean values. So I'll do a couple examples over in the console. We're not really going to do a lot of this type of thing in our P5 stuff, but it's just good to kind of understand what's happening. So if I want to know if something is true or false, I can use a Boolean function just to evaluate it. And so if I say what's the Boolean of true, that's going to be true. So a Boolean value can either be true or false. If I say something like type of true, it's going to say that's a Boolean value. Type of false, that's a Boolean. So I can assign true or false to a variable. I could say variable is it cold equals today. It's not as cold as it usually is. So let's say it's false at this time of year. So is it cold? Now we know that value is false. We can also say something is true. So we could say, is it Monday? That's true. And so now if my program wants to know if it's Monday, whoops, it can look at that data and know that it's true. In JavaScript, things can be evaluated to be a true or false. So if I say like, what's the Boolean of 0, that's actually false. There's no real reason why that is. It's just a weird JavaScript thing. Like the Boolean of 1 is true, but the Boolean of like basically any other number, like -1 or infinity or negative infinity, everything that's a number is true if it's not 0. That doesn't really matter that much. It's just kind of a weird quirk of the program. But some error types or some like undefined types are also Boolean values. So if I say like, what's the Boolean of undefined, it's false. And that's actually kind of useful because if we have a variable like x, but it's not defined, we could ask, is it defined very easily. We can just say if x, and that's going to be undefined. So it is kind of useful in some cases, but it's not something that we use a ton. Okay, so the way that we actually use these true or false values is with an if statement. If is essentially just setting up the idea that we're going to compare a value. So if something is true or if something is false. So just like we are when we're making our decision, we're going to say if the weather is cold, then we're going to wear a jacket. And so when we write a Boolean statement, we're going to use an if. So let's set up, I'm going to go over to P5 and make a new sketch, and I'll set up an example. So we've used mouse X and mouse Y last week. There's other values that we can use that tell us other types of information. So mouse is pressed is a Boolean value like mouse X or mouse Y that tells us if the mouse is pressed. So if I want to use that condition in my sketch, I can, let's say we go under draw and I say if. So any Boolean condition is going to start with if. Let's say, or this is really a conditional statement. So it starts with if, and then we use parentheses to contain the condition. So we have these parentheses right here. It's a little bit like we see with our function, but they have a different purpose. We have to put our condition in there. Yeah.
Is there a difference between mouse pressed and mouse dispressed?
There is. Yeah. We'll see that in a second. Okay. So inside the parentheses is the condition, and the condition has to be either true or false. But lots of things can be true or false. And so we'll go over a few of those things in a second. For now, let's just use true. So we'll just say if this thing is true, and you'll notice true by itself turns pink because it's a value. So we can't like name a variable true. So after we evaluate our condition, we're gonna run some code in between these brackets. So we have a new code scope. This is something that we haven't seen a lot of, where we have one code scope that's inside of another code scope. So we're inside of the draw function. We have these two brackets, and now we're making a whole new separate scope within the draw function, but it's still contained inside the draw function. And we can do this, infinite times. That's how most programs work. We have like little parts of our program inside other parts. So in between these brackets is the code we want to run if the condition is true. So let's say we just want to draw a circle. So I'll draw a circle in the middle of our canvas. And so we can see if our condition is true, then we get this circle. Okay, if I change this value to false, we get no circle. Okay, so whatever's inside these parentheses, if it ends up being true, then whatever's inside this code, and we're just drawing one circle, but I could do lots and lots of other things. I could draw images, I could draw text. Let's put a text here that says true. And we'll put it in the middle as well. Or let's just call it conditional. I don't want to be confusing. Okay, so if I change this back to true, then we see whatever is in that code. And if it's false, or if it's something that ends up being false, we'll see the same thing. So if I have no condition there, I'm going to get an error. Okay, so it's going to say unexpected token. You have to have something here. You have to have some condition that exists for the code to understand what's going on. If I put a 0 here, nothing's going to happen because 0 resolves to false, which is a weird JavaScript thing. If I put a 1 here, it considers that to be true. So there's some weird things like that, but for the most part, you don't really have to worry about it. Okay, so let's look at a type of statement that can be true or false. So we saw that mouse is pressed. So this is different. If we have a function mouse pressed, we've seen that function before. That runs some code when we click on the canvas. So we could just console.log mouse pressed. But mouse is pressed is like mouse X or mouse Y. It's just a value that's either true or false that changes, that is consistently updated to match what you're doing with the mouse. So I'm going to change true to mouse is pressed. And let's also put that inside of our, well, actually, I'll put some text here in a second. Okay, so now I have my mouse. I'm not pressing it, so we don't see anything on there. And then if I hold my mouse button, now we see the circle and the text. And it doesn't matter which mouse button I use. If I use the left mouse button or the right mouse button, although if I use the right mouse button, it does open this context menu, which makes things kind of goofy. I can also use the scroll wheel button. It doesn't actually matter which button I'm pressing. All this is telling me is whether some button on the mouse is pressed. And Booleans or true-false values are usually formatted in this way. Is pressed versus mouse pressed. Mouse is pressed is sort of like a question. Is the mouse pressed? And the answer is either yes, it is, it's true, or no, it's false. So we can see that if we put some text here. I'll put a text and just put mouse is pressed in here. We'll put this up in the top corner. So you can see it's true when I'm clicking the mouse, and it's false when I'm not clicking the mouse. And then we can also see, you can see down here, when I'm clicking, I'm getting this log because I have this mouse pressed. But mouse pressed is different. Actually, if we put this in here, it's going to look kind of funny, but we can see what that looks like. So this is actually, you can see the mouse pressed is this whole function. So it's actually printing out that whole function. So mouse pressed is a function. Mouse is pressed is a true or false value. Okay. So we'll do a couple more things, but any questions so far? Yeah. Yes, but we'll look. There's a few more things that we can put in there. Yeah. So yeah, let's do some more stuff with our conditions. So I'm gonna just add some more stuff down here. So we have mouse is pressed. It can be true or false. But we can also do comparison. So not everything is just either true or false. We can also compare numbers or other types of data. So there's a bunch of different operators for doing basic comparison. The double equal sign is to compare two values. So remember when we first learned about the equals operator, the single equals sign, I talked about how that's actually an assignment operator. It doesn't really mean equals like what equals means in math. It really means that a variable gets a value, and that's why I use the verb gets when I'm talking about that operator. The double equal sign is actually what equals in math means. It means that the value on the left and the value on the right are the same value. And so we can compare values. So for instance, I can say if, let's say 1 double equals 1, let's draw a square. So I'll draw a square. I'll put it at 100, 100, 100. Okay, so we get a square because 1 does equal 1. The result of 1 equals 1 is true. So it's like if I just wrote true here. But It's just 1 equals 1. And we can see that if I open up the console and I want to know if this is true, I can say 1 double equals 1. That says true. 1, of course, does not double equal 2 because the value on the left is not the same as the value on the right. Okay, so evaluating whether 1 equals 1 is not super useful, but we can evaluate more useful things. This one is a little weird. This is the exclamation point before the equals means they're not equal. Okay, so two things are not equal. So if I change this to not equal, 1 does not equal 1, even though so this is a little bit of a double, it's a little confusing, but what I'm saying is 1 does not equal 1, and that's true because 1 does equal 1. So if I say 1 does not equal 1, that's not going to run because that's false. 1 does equal 1. Okay, so that's where conditions can get kind of tricky. We're not going to do a ton of stuff like that, but that is one of the possibilities. So I can say 1 does not equal 1. That's false because they're the same. If I say 1 does not equal 0, that's true because 1 and 0 are different values. We can also, we can also compare greater than, less than. You've probably done this in math. A number can be greater or less than another number. You can also do greater than or equal to, less than or equal to. These guys I'll mention briefly, but we don't really need to worry about them. The triple equal sign basically means the values are the same and the type is the same. That's because in JavaScript we can get some kind of weird things with our values where we know that 1 equals 1, but you might be surprised to find out that 1 also equals the string 1. But 1 does not triple equal the string 1 because the number 1 is a number and the string 1 is a string. So the triple equal sign actually evaluates type as well. We don't really need to use this a lot, but if you look up JavaScript examples, you'll see this. And so just so you know that's what that means. Okay, so let's look at some comparisons. So one thing I might want to know when I'm working on a design is where the mouse is on the screen. Okay, so let's say if mouse X, and let's say if mouse X is greater than 100. Okay, so if mouse X is greater than 100, let's change our color to red. And we'll draw another square. This time I'll put it at 300. Okay, so now I'm running this sketch, and you can see when my mouse gets past this point of 100, we see that square appear. If it's less than 100, there's no square. So the mouse X value, whatever number that happens to be as the mouse moves across the screen, once it gets to be greater than 100, we can also say greater than or equal to. This won't make a huge difference, but it'll just go 1 pixel earlier. So if the mouse is greater than 100, we get this square over here. So we can compare different values. That's useful for knowing where the mouse is on the screen. You can have different things happen, different screen. Eventually, as we get to things get a little bit more complex, we'll add multiple conditions together. And this is where you get things like buttons. Like if we click on something, like when I click on the tab at the top of Chrome, how does the computer know that that's where I'm clicking? It knows because it can compare this size and position of this like little tab thing to the position of where my mouse is. So the way that all of these little buttons, everything that we click on the computer, the way that they work is by using these types of conditional statements to figure out where the mouse is, if I'm clicking the mouse, all these different things. So these are like the very, very bare bones of how pretty much all of our computer systems work. Okay, let's see some more examples. Okay, so when we are having a condition, when we're asking a question, there's like sort of a positive response to that question. If it's cold outside, I'm going to wear a jacket. But then there's a negative response to that question, which is if it's not cold outside, what do we do instead? So sometimes a condition is simple. It's just if this thing happens, do this other thing. But sometimes it's if this thing happens, then do this thing. But if it doesn't happen, do something else. That's where else comes in. So else comes after if. If the thing is true, do the first thing. If it's not true, do the second thing. And we can start to like stack these up. We can have if statements inside of other if statements. It starts to get very complex. But this is sort of the first basic level of complexity. So let's say I want to draw the same square, but I want it to be a different color. So I'll move the square, out of my if statement. So I'm going to draw the square either way, but I'm going to make it red if I cross a certain line. And let's draw this square at 100 just so it actually lines up with where we're drawing. Okay, so now you can see when I cross the line, it turns red, but now it just stays red. I don't have like another condition. So let's add a condition here. So to make an else condition or statement, I just go to the end of the if statement. It has to come directly after the end of the if statement. I can't have like some other stuff happen and then write else. So right after this if statement, I can put in else, and then I just go straight to my code. So this sets up the original condition. The else statement is just whatever happens if that first condition isn't true. So I don't need another parentheses. I just go straight into the curly brackets. Okay, so else, I'm going to fill green. Okay, so now it's green unless my mouse crosses this threshold. So right now, they're matching, but they don't have to. If I change this number to 200, it'll do the same thing, but just over here. So I'm lining it up just to make it clear when that change is occurring, but it doesn't actually have to, it doesn't really matter if it lines up visually. It's going to take whatever number we say. So if the mouse X is over here, the number is lower than 200, then we get the green fill from this else. So if the mouse X is not greater than or equal to 200, this statement is false. And so we skip the first section and we go to the second section, the else section. So we see on the right, we have red, on the left, we have green. And again, you know, we can map this to a line that when we mouse over something, we can change the color, or we can make something happen. We can create more specific events than just clicking, you know, somewhere on the canvas. All right, that's our else statement. Okay, we also have else if. Okay, so this is where we start to really add up a lot of conditions. So if and else don't give us enough to work with, then we can add stuff in the middle. This is where it starts to get tricky. I'm gonna create a new window or a new project. I'm gonna name this Conditionals Part 1. And so we'll do another example. And this one is a little bit trickier because this is where the order kind of starts to matter. So I'll give you guys an example of that. So let's make a new sketch. It wants me to save. I thought I already saved, but let's just save and make a new sketch. Okay. So this is our else if. And what I'm going to do, I'm going to make a little stoplight example. Okay. So in our stoplight, we have three options. We have the red at the top, which means stop. We have yellow in the middle, which means get ready to stop. And then we have green at the bottom, which means go. Okay, so if we want to be able to display three different options, then we need three possibilities, three different conditions. There's a few different ways we can do this. One of the things that gets kind of tricky with programming with logic and decision making is that there's lots of different ways to express the same basic idea. You could say, is the mouse at the top of the screen? Or you could say, is the mouse not at the top of the screen? And then make decisions about that. So we'll try to go through it in a straightforward way. So we'll set up our first condition is the red stoplight. So we'll start with the red light. So what we can do, let's make our sketch a little bit bigger. We'll make it 600 pixels tall. Or no, that's wide, sorry. Make it 600 pixels tall. It's a little too big for our window. At least my screen is kind of small. So let's make it 300. Just make the math easy. Just for this. Okay, so we can draw a red light. So if I want to draw a red light, I would draw a circle. I would draw... First, actually, I would want to change the fill to red. Let's turn the stroke off. So I'm going to say no stroke in setup. So I'll draw a circle. I'm going to draw it in the middle of the canvas. I'm going to draw it at the top. So I'll draw it at 100. And I'll make it 100 pixels wide. And actually, since the circle draws from the middle, let's draw it at 50 pixels. Okay. So there's our red light. So the condition that we can set up is we only want to draw the red light if our mouse is in this area up here. So there's a couple different ways we can do that. Let's just go with the simplest way. We can say, we can think of dividing our canvas into 3 sections. So it's 300 pixels tall. So each section will be 100 pixels. So we'll just divide it up into 3. And we can start by saying, so we can say if, and for this one I'll use mouse Y because we're going from top to bottom. So if mouse Y is less than 100 pixels, then we're going to draw our red circle. Okay, so now if my mouse is up here, we see the red circle. If it's down here, we don't. So we're just drawing this one cutoff line. And if it's less than 100, we draw it. If it's greater than 100, we don't see it. Let's draw our mouse Y value so we can see what that looks like. And I'll just make the text size a little bigger. Okay, so you can see that number is just the mouse Y. So you can see it's 0 when my mouse is up here. And as my mouse moves down, the number gets bigger. And when I get to 100, we leave that first section, so the mouse is no longer less than 100, and so we don't see that circle anymore. Yep. I'm just using the text function, and I'm putting the mouse Y value as the text that I'm drawing. Other questions? Okay. All right. So now let's draw a green light. So if I draw a green light, I can say if, just go to the next section. If mouse Y is less than 200, let's do a fill. Let's do green. Or no, we're on yellow. Whoops. What comes after red is yellow. Although I guess yellow technically comes before red. Anyway, we'll fill yellow, and we'll draw a circle, and we'll draw it in the same X in the middle. We'll move it down to 150, and same size. Okay, so now we get our red circle, we get our yellow, and they both disappear, but we have a problem, which is that when I'm in the top section, we see both, right? Because when I'm up there, the value of the mouse at Y, if it's like, 30 or whatever, 30 is less than 100, so we get red. But 30 is also less than 200, so we also get yellow. Okay, so if I don't want that to be the case, there's a couple of things I can do. The easy thing to do is I'm going to move this comment. Let's put this comment inside here just to make this a little easier to read. So what I can do is put an else in between these two guys. And I can actually put those together. This is the else if. So if I say else, and then I move this if back here, it actually doesn't matter as long as there's nothing else in the middle where I put it. But that's usually how I'd write it. Now, this if that's true, we ignore the second part. With an else if this first part is true, it runs this block of code, and then everything else it skips over because the first block is true. Okay, so if the mouse is less than 100, we get our red circle. If it's not less than 100, we skip to our next condition. So our next condition says else if mouse Y is less than 200, we get our yellow circle. Okay. Now, when we go to the bottom, where neither of those statements are true, and we don't have an else, so we don't get any of that code. Last bit, you might have already realized that we don't need a condition anymore because we only have 3 possibilities. So I only need as many conditions as I have possibilities minus 1, right? Because else will do everything that doesn't meet the first 2 conditions. So if I say else, I'll say this is my green light, and I'll draw a circle, and it'll be at 200 and 250 and 100, and don't forget to make it green. Okay, so now we have red, yellow, green. And so because I don't have a specific condition for my green light, but the first 2 conditions exclude the final condition. So if the first 2 conditions are true, if either one of those is true, then we know the final condition is not true because we just have 3 possibilities. So this isn't always going to be the case. Sometimes you have 4 possibilities or 100 possibilities. But in this specific instance where we have 3 possibilities, we don't need to ask the last else. We could, if I put else if mouse y is less than 300, that's not going to change the code at all. It's doing the same thing, but I don't have to do that because I already know that condition is going to be there. But you know, if I had a larger sketch, if I had more stuff going on here, like if this was, you know, 400 or something like that, then I might want to have it end at that point. But I don't. I have what I had before, so let's just leave that. And so I've got my little stoplight. Okay, so the logic stuff starts to get a little tricky. It's going to take a little bit of practice, but that's kind of the basic idea. It gets a lot more complex because we can put conditions inside of other conditions. We can put if statements inside of other if statements. So you can make things more complex. We're not going to do that right now. We might do that in future lessons, but we're just going to go over the basics for now. Yeah. Right. Yes. Yeah. And if you try to, you'll get an error. So, you know, if I put a condition after my else, like that, it's going to tell me, you know, it doesn't expect, it says unexpected token. But what it really means is that I shouldn't have had this here. Okay. So one thing that you might see, this isn't something we're going to use a lot, but one thing that you might see in some examples, if you're looking on Stack Overflow or something like that, you may see something like this. If true, console.log true. Where you basically have a conditional statement that's just one line with no brackets. This is technically a valid piece of code. If I run this, it is going to log true. This is the same thing as saying if true, console.log true with the brackets. This is a pretty common thing in programming languages when we have things that are kind of, we have some sort of like shortcuts. If we have things that we just can express as one statement, we don't have to add the brackets, which usually people format to have multiple lines. The problem with this is that if you have 2 lines, it looks like you're saying if this is true, and then you have 2 statements, but this actually only applies to the first statement. When we get to the semicolon, we're out of the if statement, and the next part is going to run as though we didn't have that if statement. So again, this is not something we really need to use in this class, but it's something you'll see if you're looking at programming examples. You'll see if statements with no brackets. So if you see that, this is what you're looking at. In this class, I'm always going to use brackets just to, you know, keep consistency with our styling. Okay. So these are some nested and compound conditional statements. I feel like we can skip this for now and come back to this later because we've already, I think this is enough complexity to start with. We'll probably talk about these next week. Actually, we'll do some animation and we'll have to use these. So let's wait for that. So I'm gonna stop here and just give you guys a bit of time to kind of play around with conditional statements. In the second part of class, I'm going to go over using a conditional statement to set up our kind of like interactive comic example. And I'll talk about how that's going to work. But for now, just try playing around with these different values and seeing if you can get different effects. You could start with the interactive sketches that we made last week. So a lot of you guys made sketches where things are changing color or size or shape. See if you can throw a conditional statement in there to get some different effects from that. But yeah, we'll just take some workshop time. Any questions before we do that? All right.